Today we're going to do lesson 4.7, and we're talking about piecewise functions. So our essential question, how can you describe a function that is represented by more than one equation? Now, piecewise is exactly what it sounds like. We're going to take multiple functions and we're going to graph pieces of those functions. All right? Now, when we have graphed functions in the past, what do the graph of functions look like? What is their shape? What are they? They're lines, okay? So we're going to take a piecewise function. We're going to take a function defined by two or more equations, and when we graph them, instead of graphing the entire line, we're going to be graphing pieces of those lines. So each piece of the function is going to apply to a different part of the domain. Now, let's talk about domain. Domain is what set of values? The x values, all right? So that would be, if you have forgotten that the domain is x values, that would be a good piece of information to add. Now, let's interpret a piecewise function, because you wrote down a problem that you have never seen before. So you'll notice outside of the brace we have f of x. What have we learned f of x also stands for? Y. So don't be alarmed when you see a problem that instead of f of x equals, it says y equals, because it's the same exact thing. All right? In this problem, I've given you two functions. And what I need to make sure is that you can actually see and pull out the two functions. So we've got one function here. So you can see when I brought it down here, I wrote the whole equation. F of x equals, and I brought down the negative x minus 3. That's our first function. Now that function has a boundary. I brought that down as well. I can only plug values for x into this problem that are less than or equal to negative 3. So that's my boundary. I can't just plug any x value that I want. For this particular function, I can only plug in x values that are less than or equal to 3. Now, the second function in this problem, if you can see right here, and I brought it down right here, is f of x. Again, I got to bring the whole thing down. F of x equals x plus 3. Now, the boundary for this function says that my x values have to fall between negative 3 and 0. So negative 3 is less than x and less than 0. So the boundary for this function is given to me as negative 3 is less than x and less than 0. So I can only plug x values into this problem that fall between negative 3 and 0. All right, everybody with me so far? Now, in example number 1, it asked me to evaluate. All right, and what does the word evaluate mean? To solve. Again, if you can't remember that or you have forgotten that, that's a good thing to write down. They want us to solve the function. Well, what am I solving the function for? I'm solving it for y. Awesome, because we got f of x here, and again, we know that that stands for y as well. Now, let's look at a, b, and c. Again, this is all review so far. If I have a number inside of the parenthesis instead of an x, because normally, if I look right here, normally it's f of x. What are they telling me when they have f of negative 8? They're telling me that x is equal to negative 8. They have taken out the x and replaced it with the value of x. Very good. So let's write this down. So Drew, on f of 0, x equals what? 0. Good. And letter C for f of 10, they're telling me that x equals 10. Now, I'm supposed to evaluate the piecewise function, but notice the sentence that we wrote down. The x value you are given to plug in can only go into the function where the value falls within the given boundary. So we have to take each of these x values and we have to find out which function we actually can plug it into. All right? So let's go through this. Again, I'm going to go through this slowly, but stay with me. All right? The first boundary, the first function is f of x equals 3, right? The boundary is right here. So the question is, we plug in negative 8. Is negative 8 less than negative 2? Yeah. So we can plug negative 8 into the first function. So let's bring it down. What is the function we're bringing down? F of x equals 3. Okay, now we'll come back to it. Let's check the next boundary. We're going to check these values in every boundary because sometimes it may be able to go into more than one function. All right, so let's check the boundary here. Does negative 8 fall between negative 2 and positive 5? No, so I know I can't use that function. And lastly, is negative 8 greater than 5? No. So the only function I'm allowed to use is f of x equals 3. Now, don't let this confuse you. We know that f of x is the same thing as y equals 3. So what kind of line would that be if I graphed it? See, everybody panicked on their test. Listen, the problem didn't have an x in it, and you guys panicked and thought you didn't know how to do it, or you put an x in the problem, magically it appeared. Okay? What kind of a line is that? It's horizontal. So it is a graph. Even though there's not an x in it, it is a graph. So is there anywhere in this function for me to even plug that x value? No, there's no x in it. The function is 3. F of x equals 3. So if there's nowhere for me to plug it, then this is my answer. Okay? If I go to -8 on this line, my y value is 3. So that's my answer. All right, now let's check 0. Let's chart here. 0 is less than -2. Yes or no? Nope, so I can't use that function. Does 0 fall between -2 and 5? Yep, so I can use that function. What is the actual function that I'm bringing down? F of x equals x plus 2. Awesome. And lastly, is 0 greater than 5? Nope, so I can't use that function. All right, awesome. So what is the x value that we're plugging in? 0. What is 0 plus 2? So f of x equals 2. All right. Letter C. The x value is 10. First boundary. Is 10 less than -2? Nope. Second boundary. Does 10 fall between -2 and 5? Nope. Third boundary. Is 10 greater than 5?
Yes.
So which function are we using for letter C? F of x equals? That's not the function. So it's the boundary that you're telling me. Okay? If this is the boundary, this is the function. So f of x equals 4x. And what are we plugging in place of x? 10. Plug it in parentheses because we don't want to think 410 is our answer. Our answer is actually 40. All right? And maybe I didn't make that clear. If this is the boundary, this is the function. For this boundary, this is my function. Okay? The boundary is always sitting next to its function. Any questions? All right. Now, in example number 2, they ask us to graph the piecewise function. So we have to take these two functions and we have to graph pieces of them. Okay? We have to graph pieces of them. So this is where I want you to get out your phones and I want you to open Desmos. All right, we're going to allow Desmos to do a majority of the work for us. All right, so here's Desmos. And you can see if you click on this box over here to the left, this is where we're going to type in our functions. Now remember, you have to type in the entire function starting with y equals. All right, so everybody in their notes should be looking at example 2, letter A. All right, TJ. What is the very first function for letter A? Okay, it's not f of x though. Don't we have y this time? So y equals, now, in this bottom left corner, you see the little keyboard? If you hit that, it'll bring up all the pieces that you need to type in your functions. Okay, so it's y equals, what's the first function, TJ? X plus 1. So we're going to type in x plus 1. Now, you'll look at the graph and Desmos has given us the entire line. But remember, this is a piecewise function, so we're only looking for a piece of it. So we're going to hit this ABC button down here in the left corner and see about 4 spaces over, you have the little braces right there. Click on it because that's where we're going to put the boundary. Okay? Once you have the braces, go ahead and hit that 1, 2, 3 button. And let's look at the boundary. TJ, what is the boundary for that function? It's right beside it. All right, so x is less than or equal to 0. Now if you look at the graph, see how we only have a piece of it. The whole thing is no longer there. All right, now hit this little round, the arrow down there that's kind of rounded, and that will take us to our next line. What is, Alonzo, our second function in this problem? Y equals negative x. Okay, see we've got the whole line. Hit the ABC button, hit the braces, hit the 1, 2, 3 button. What is our boundary, Alonzo, for this function?
X is
greater than 0.
X is greater than 0. Now do you see how we only have part of the line? Okay, if I hit the keyboard, it'll go away and I can see the different parts. All right, now we have just talked about boundaries. And if you notice where one line stops and the next line starts, that is what is called the boundary line. So when you go to transfer this onto graph paper, which is what we're about to do, all right? So put Desmos down, put it beside you so you can see it, okay? Or you can look up at the board, okay? Now we have to take what Desmos has done and we have to transfer onto paper. Well, there's a couple of things that Desmos is not showing us right now, okay, that I want to see on your graph, on your paper. So this is where you got to stay with me, all right? First thing we're going to graph is the boundary line. Ms. Johnson, where do I get a boundary line? Well, if I bring the keyboard back up and I hit the arrow, I've got another equation that I'm going to type in, okay? The boundary has everything to do with x, right? X is less than or equal to 0, x is greater than 0. So x equals, I am going to graph a vertical line. That is called my boundary line. So x equals, well, look at your boundaries. What is the number or numbers that you see in both of your boundaries? 0. So there's only one number, so all I have to type in is x equals 0, and I now have a boundary line. Now it's green, and it's laying right on top of the y-axis, so it's kind of hard to see. So let me teach you something else. If you hit the little wheel up here at the top, it's going to allow you to change the color of your lines. It's going to allow you to change your lines to dotted lines or dashed lines if you want. So first thing we're going to do, click on the red dot, and let's change it to blue. Okay, that way both pieces of our problem are the same color. And then go down to the green, go down to the boundary line. Let's make it red, and let's make it dashed. All right? So you're going to click the red circle to make it red, and then you're going to hit this button right here, and it'll make it a dashed line. Now, on your paper, all right, pick up your pencil or your highlighter. Since it's right on the y-axis, the highlighter might be a good idea, but I want you to draw that dashed boundary line. Because here's what you got to understand. The end points of your graphs have to be on your boundary lines. So you've got to know where your boundary line is. All right, so I should see pencils in hand, and I should see everybody drawing, do a dashed line all the way down your y-axis, because that is where your boundary line falls for this problem. The next thing we have to decide is our endpoints. If you're looking at your problem on Desmos, it's not very clear, okay? It doesn't really give me those endpoints, but on your graph, you have to actually give me endpoints. So if you want to zoom in, all right, don't zoom in. I hit the zoom in button twice. I hit the plus twice, and that's good because now I can see some points very clearly. Where does my first function hit the boundary line? At what ordered pair?
0, 0.
Okay, nope, it's right here. There's my end. There's the end of my first function. Where is it hitting the boundary line? Not 1, 0. 0, 1. Okay, so on your paper, on your graph paper, you're going to go, all right there at the ordered pair 0, 1 is where we're going to put our endpoint. But before we do it, let's look at our boundary. Okay, go over here and look at your boundary for the first function. If our symbol is less than or equal to, is our point going to be open or is it going to be closed?
Closed.
Closed. Okay, remember, or equal to tells me closed. So my endpoint is going to be a closed point. Now, on your graph paper, you've got your boundary line, you've got your first endpoint plotted. How do I want you to draw the line? I want you to take your ruler, I want you to line it up with your endpoint, and I want you to find one more point on the line. Okay? Let's find one more point on this line. Does everybody see this point right here?
Yes.
Now, you don't have to actually draw the physical point, but make sure your ruler or your straight edge, whatever you're going to be using, is lined up so that your line crosses at -1, 0. All right? Because you've got to draw the correct line. So it's great if you have the endpoint correct, but the rest of the line has to be correct as well. So find one more point on your line and just make sure your ruler is lined up so that your line goes through that point. If it would help you to actually draw the point on your graph, I'm okay with that as well. But remember, Desmos is doing most of the work. You still have to produce the same answer on your paper. Okay, now look. The first function ends at the boundary line. The second function begins at the boundary line. Where does it begin? At what ordered pair? 0, 0. Again, though, we got to look at the boundary. Is my circle going to be open or is my circle going to be closed? Because it's just greater than. So on my boundary line at 0, 0, I'm going to draw an open point. An open point. Line your ruler up. What's one more point on the line that your line needs to go through? How about right there? What's that ordered pair?
1, -1.
1, -1. So either plot it and then draw your line, or at least have your ruler line up with that point. And of course, you're going to draw arrows on the ends of the lines that are not at your end point or your starting point. Okay? We can continue on this same Desmos if we want to, but in order to do that, we've got to make these go away. Okay? We want to make these lines go away. So in order to do that, all you got to do is go to the blue circle and click on it. When you click on the blue circle, it takes it away. Click on the other blue circle, the graph goes away. Click on the red circle, the boundary goes away. So this just keeps you from having to open a whole new page. Now, we want to click on the x = 0 and we want to hit the arrow. All right? Look at letter B. Everybody has letter B in front of them. Let's at least get this in Desmos before class ends. What is the very first function of letter B? Y = 1. Hit the ABC, hit the brace, hit the 1, 2, 3. What is the boundary for y = 1? X is less than -3. Awesome. Hit the arrow. What is the second function? Y = anybody? X - 1. Hit the ABC, hit the brace, hit the 1, 2, 3. What is the boundary on this one? All right, -3 is less than or equal to x and less than or equal to 3. Awesome. Hit the arrow. We got one more function. Y = what's the last function in this problem? -2x + 4. Good. ABC. Brace. 1, 2, 3. The boundary for this one? X is greater than 3. Now, I'm going to hit the wheel. I'm going to make all 3 parts of my graph blue. All right, I like since this is all one problem, I like to make all 3 graphs the same color. Right, and then I'm going to hit done. Now, what's the first thing that I've asked you to graph on your line? And I've got to zoom back out because I zoomed in for the last problem. What's the first thing that's going on your graph paper? Nobody? What's the first thing? Go look at letter A. What's the first thing we drew on our graph paper?
The boundary line.
The boundary line. So we have boundary lines. Look at your boundaries. What number or numbers do you see in your boundaries this time?
3.
You see a 3. I see a 3. Anything else? I see a +3, but I also see -3. So how many boundary lines are we going to have this time?
2.
We're going to have 2. So we're going to do x = 3. Hit the enter button. X = -3. Then we're going to hit the wheel. We're going to make our boundary lines red and dashed. Okay? We're going to make them both red and dashed. Okay? So see them now? I've got one line going through -3. I've got one boundary line going through +3. So get that on your graph paper, and that's where we're going to stop for today.